So, Rajkumar, is there any problem in interference regarding screen or any audio problem to anybody? Please immediately WhatsApp me. I have also make a WhatsApp on my screen also, so that I can really come to know all the things. Fine.
Okay.
So, so today we will here. This is the dedicated theory lecture. So in the last 15 minutes or 10 minutes, we will review regarding some hands-on practical sessions, or I will give you tips how to study or how to study the coding. So later on, after the session, I will post on links on the Google Classroom theory. So study that thoroughly so that you can get how the coding, embedded system coding can be done in C. So prerequisite is that your C programming, there is a requirement of fundamental C programming coding language. So it will be helpful for you to develop embedded C codes. And also, there is my request from my end is that you should purchase that Majdi book. So if you refer hard copy, then it will be well and good, since that book is available in market. You also, or you can buy it from Amazon or Flipkart. Then next thing is that today we will study the basics of microcontroller. We are started the unit. I think 1 week has been elapsed. So you come to know the basic ins and out regarding to the microprocessor controller. What is the exact difference between all of both of two, and what are the applications of that? So then, so also we have just gone through the what are the register addressing modes in that register addressing or direct addressing, register indirect addressing. Study the instructions on that. Those link I will provide you on the Google Classroom. So that contains all this stuff in detail. You study that properly, and if you have any doubt, then you can post me on the Google Classroom or on email. So this is all these are the theoretical. There is a definite questions on your ESC or CT1, that is explain the addressing modes with respect to the 8051 microcontroller. So for that, you have to define what is addressing modes. It is nothing but the way of specifying data to be operated by an instruction. It is nothing but the addressing modes. And we have, in case of 8085, 5 types of addressing mode, namely register addressing. In that, meaning is that the content of one register can be transferred to the another. So that is nothing but the register addressing. Here they have given one example that move a comma b, that is contents of the whatever b register that can be shifted to the accumulator, then add b. Now addition of that accumulator content with the b and stores data to the a. Then increment a, increment the contents by 1. So like that, direct addressing mode. In direct addressing mode, the data to be operated is available inside the memory location, and memory location is directly specified as an operand. An operand is directly available in the instruction itself. For example, just to look out, we are seeing the assembly language coding now. So LDA 2050. The meaning of instruction is that the loading of the contents of that memory location into accumulator. Means, for example, suppose memory location 2050 has a data, 25. So that 25, that 16-bit data can be loaded into accumulator. The next instruction is that LHLD. You take one notepad along with you and just write down these instructions and that meanings, because there is a question like in CT1 exam. So explain the instruction LDA 2050 along with the example. So, or explain direct addressing mode. Or there is a question, single question is like, explain the following instructions of the assembly coding of the 8051. So in that, there will be question maybe like that, move A comma B, or LDA 2050, LHLD, SHLD. So, or in 35, you have to write the exact meaning of that particular instruction. So what do you mean by LHLD? Load the contents of 16-bit memory location located by HL register pair. So if H carry 20 and L carry 00, means whatever the content of memory location 2000 is loaded in register HL register pair. Just wait. There is a LHLD into address. Syntax is like that. LHLD address means LHLD 4000. Suppose there is like that. So what it that do? The load the contents of memory location means whatever the contents of 4000 memory location that can be loaded or pushed into H and L register pair. So in if you refer the book much, all these instructions or all the things, or also whatever the content I am loading you in the classroom, all the details has been given in that. You go through that. Also, there is an instruction like that. That instruction is called as a direct addressing. Directly, we are pushing the data into registers as well as any port. For example, in 35, read the data from port whose address is 01. Then register indirect addressing mode. So in this case, the example maybe that the data to be operated is available inside the memory location. Whatever the data that has to be operated, that is inside the memory, and memory location is indirectly specified. For example, if there is an instruction like that, move AM, the meaning is that move the contents of memory location pointed by the HL pair. Now, in this case, M uh, by default address to HL pair. Whatever the content of HL pair, that has to be transferred to the accumulator. So that is the 8-bit data. Microcontroller 8051 process only 8-bit data, not 16-bit. Memory location is 16-bit. Keep the fundamentals clear. Then LDAXB. So this just look at the name of that. As the name indicates, this meaning is there. Just like register indirect addressing mode. Means then LDAXB. Just like move the contents of BC register to the accumulator. Then is whatever be no necessary syntax. Observe the syntax. If you write mistakes in writing the syntax, your code will not be run on kill. So LDXB meaning is that move the contents of that BC register to the accumulator. Then LXIH, that is immediately whatever the content of at the content of that memory location 9570 into HL pair. Suppose 9570 has 15 data, and that 15 data is loaded into HL pair. Are you following, all of you? Just reply in the chat box whether it is not going fast. Shailesh, Rajkumar, is it fine there? Please reply. Are you following, all of you? Please reply. Otherwise, please reply everybody. Rushikesh says yes, fine. And Pooja says yes, Nehal says yes. Okay, fine. That's everybody getting the things. Please reply all other students also, so that I come to know whether the things are going to each and everybody. Siraj says yes. So next thing it is that implied addressing. So just read whatever written on the screen. That is implied or implicit addressing mode to the operand is hidden, and the data to be operated is available in instruction itself. Examples CMA means there is no operand operate, just whatever the processing is done at the back end. What is the meaning of the CMA is that it finds and stores the one complement of the contents of accumulator A in A. Just I am also not getting clarified with this CMA. Go through the book or Google, you will find the answer. Then RRC, that is rotate accumulator A right by 1 bit. Then RLC, rotate accumulator A with left 1 bit. We'll see in detail at the time of coding. So this is in short related to the addressing modes. That basics of controller, but it is a block diagram we have seen earlier. No necessity to repeat. Then contents of this PPT. These are in brief. In first unit, we are going to study the block diagram, pin description, registers, memory mapping, stack, IO port programming, timer, etc. Then why do we need to learn microprocessors or controllers? So as you know that microprocessors are the core or heart of the computer system. Nowadays, many communication, digital entertainment, portable devices are controlled by them. A designer should know what type of components he needs, best to reduce production cost and product reliability. So as you know, there is a huge competition in the market. So designers' challenges or objective is that minimize the cost, production cost. Also, while minimizing means we are there is a trade-off in procuring the materials. So there is a trade-off between cost and quality product or reliability. If I less down the cost of the product, naturally not necessary product will be real reliable. It has a less durability. So there is a very challenging task to the designer how to get a sandwich in between that cost, the production cost, and the reliability of the product. I will give you the real-time better example for this is if you want to suppose you want to buy a new smartphone. So in the that segments of smartphone, the Apple is the plays leading role, but its cost is very high, very durability, and it is very user friendly. On the contrary, there are a lot of mobiles in the market that is developed by China, just like Realme, Samsung, or any other. There are Nvidia, any number of productions are there. But if you want to purchase the mobiles, if your budget is 10,000, then at that time selection. So now designer's role comes in picture that he has to give you the services, give you the product at less cost and better features. But while if you see the cost of the Apple and compare it the cost of that with the Samsung or any other Chinese mobile or Vivo, so you will get that trade-off or depending upon the requirement, you may select that. So that organization objective is that to achieve they firstly decide the target group on which target group, just like Apple targets to the rich and high-end class, and it gives the services. They work on the every segment on the research how to make the product more and more reliable, how the features can be enhanced. But on the contrary, that Samsung or other players, what they do, they target on the masses so that maximum products should be. That is the difference, means end-to-end difference in between these two. So the meaning of the explaining you in detail is that how there is a production cost and there is a trade-off between production cost and reliability of the product. So you consider the different aspects of the processor and controller. It both has the hardware that is nothing but the interface to the real world. Means I am utilizing this laptop. Means my voice. I am interacting with the hardware. That is so that my voice is going into the laptop and to all you. And software, it is a backend code that how order how to deal with the inputs. Whatever I giving inputs to the keyboards or my voice, that can be processed at the back end in the operating system software. And generally, it is right on the read-only memory. So if you consider necessary tools for a microcontroller, uh, microprocessor or controller, what are the tools? That is a very important thing is the central processing unit. Then IOs, just like input and output. Maybe there may be just keyboards or mouse that are the input devices. On the contrary, that displays and printers, these are the output devices in short. Bus, address bus, data bus, these are the basic entities of every processor or controller. Then there is a internal bus system is there having a bidirectional address data bus and unidirectional address bus. And lower order address bus is multiplexed. We have to separate it out. Then there is a memory that is a random access memory and RAM and ROM. You are already familiar with this regarding memory, or we will take a. It is a very vast domain. We will take special session on memory or memory management for the 8085 processor. Then timer, interrupt, serial port, and parallel port. These are the basic entities that has to be embedded in controller. And in case of the processor is only includes the CPU and all other things. And these timers, all these things are the peripherals. So that are connected externally in case of processor. Just try to understand the basic difference in between the processor and controller. So here it is at a glance view to the what is the block diagram or internal architecture of the processor. For example, we are considering the CPU, central processing unit for the computer, and it is a general purpose microprocessor. So it doesn't has any RAM, ROM, IO on CPU itself. So just now we are just reviewing that if you go back into the history, so first processor come into picture, it was 40004, and it is implemented in the design of the calculators. I think it was invented by Japan or then afterwards, as the technology develops, Intel comes into picture, and he has designed first processor that is 8085. So it is a 8-bit processor, 8-bit data bus. But in this case, at that time, what is there? Only CPU processor, general purpose microprocessor is there, and all other peripheral ICs, just like RAM, ROM, or the IO ports. All these things are externally connected. Also, timers, also serial communication ports, also all many. There are many chips. If you observe or just type on the Google, that is that internal architecture of 8085 microprocessor, you'll get the circuits of image of the circuit, and that you can able to identify where is the that general purpose microprocessor IC is there, RAM IC is there, ROM IC is there, like that. Or another example is if you can dismantle your laptop. So at that there is a processor of i5 or i9 if it is very latest i7 or i3, whatever it may be. That depends on the specification of your device. So if you anybody, I think you have observed that dismantling the laptop, there is a RAM is there, ROM is there, and IO ports are there. So in computers, processor is used, but where the controllers are used or what are the applications of the controller? The design the embedded systems, real-time embedded system. For example, I want to design one car, and in that car, I have to embed one system. I want to give uh, automated system is there, load. So for that, embedded boards are used, and that controller has ability. That chips has ability to make the decisions as per the program, but onto that chip. So there are n number of applications. Just go to the Google, just type applications of the 8051 microcontroller, or there are numerous microcontrollers in the right now in the world. So while designing any system, very key role is that the selection of controller. Why you are going for that specific controller? Because there is selection criteria and your budget and all the things, availability, all the things taken into account, and on which application you will have to work. That's it. An example of these processors are Intel .X 86 series, and Motorola also came into this. That is 680X0 series. So this is enough regarding the processors. And controller, just example, key manufacturers in the controllers are Motorola 6811, Intel 8051, Zilog 80, Z80, and PIC16X. So these are the vendors that manufactures the controllers. So it has a facility. It is just like a smaller computer. Now I would like to give you latest example of this controller. You have seen the Raspberry Pi 3 board, very latest, very advanced. It is a general purpose microcomputer is there, embedded in a small single circuit, and you can build you can write the codes in by using IoT internet. No necessity to connect anything, and also you can simultaneously interface to 4K display to that board. I think I don't know whether you are following or not. This is very hard to understand, but I will show you that board also today. I have that one Raspberry Pi 3 kit. Just